Good morning student. Welcome to your Digital Electronics video lecture class. So I am Jyotirmay Sahu, lecturer of ETC. In previous class we have already taught about different types of flip-flop. So today we are going to learn about JK master slave flip-flop. So what is JK master slave flip-flop? The master slave flip-flop is basically a combination of two JK flip-flops connected together in a series configuration. Out of these, one acts as the master and the other acts as a slave. So this is the master flip-flop and this is the slave flip-flop. The output from the master flip-flop is connected to the two inputs of the slave flip-flop. So here the two outputs of master flip-flop are Q and Q bar. So the two inputs of slave are J and K. So here the two outputs of master are connected to the two input of slave, that is J and K. Then whose output is feedback to inputs to the master flip-flop. Then what is the working of a master slave flip-flop? When the clock pulse goes to 1, the slave is isolated. J and K inputs may affect the state of the system. The slave flip-flop is isolated until the CP goes to 0. CP means clock pulse. So when the clock pulse goes back to 0, information is passed from the master flip-flop to the slave and output is obtained. So firstly, the master flip-flop is positive label triggered and the slave flip-flop is negative label triggered. So the master responds before the slave. So first condition 1 is if J equals to 0 and K equals to 1, the high Q output of the master goes to the K input of the slave and the clock forces the slave to reset. Thus the slave copies the master. Then second condition is if J equals to 1 and K equals to 0, the high Q output of the master goes to the J input of the slave and the negative transition of the clock sets the slave, copying the master. Then third condition is if J equals to 1 and K equals to 1, it toggles on the positive transition of the clock and thus the slave toggles on the negative transition of the clock. So when last condition is when J equals to 0 and K equals to 0, the flip-flop is disabled and Q remains unchanged. So these are the four conditions of master slave flip-flop. Then this is the timing diagram of a master slave. This is the clock pulse. And according to this clock pulse, this is the clock pulse of two outputs. That is, here QM stands for the output of master flip-flop and here QA stands for the output of slave flip-flop. So, let us see the explanation of timing diagram. So, when the clock pulse is high, the output of master is high and remains high till the clock is low because the state is stored. So here in this timing diagram, when the clock pulse is high, then the output, the clock pulse of the output QM is also high. Then now the output of the master becomes low when the clock pulse becomes high again and remains low until the clock becomes high again. So here again clock pulse is high. So here the clock pulse is 0 or low. Then here the output, the master slave output clock pulse is remains same, that is high. Next condition is thus toggling takes place for a clock cycle. When the clock pulse is high, the master is operational but not the slave. Thus, the output of the slave remains low till the clock pulse remains high. So, in this timing diagram, when the clock pulse is high, then the output of the slave flip-flop is low, but the output of master flip-flop is 1. Then, when the clock is low, the slave becomes operational and remains high until the clock again becomes low. So here, when the clock pulse is low, at the time the clock pulse of slave flip-flop is high. Then toggling takes place during the whole process since the output is changing once in a cycle. So here the clock pulse is toggled. Toggle means sometimes its value is 1 and sometimes its value is 0. So when the value is high, at that time the clock pulse of the output of master flip-flop is high, but the output waveform of the slave flip-flop is low. Then when the clock pulse is toggled means changes its value from 1 to 0, at that time the output of master flip-flop remains high or 1, and at that time the output waveform of slave flip-flop remains changed. That means it switches from 0 to 1. So in this manner we can draw the timing diagram of a master flip-flop. Then what is race around condition in JK flip-flop? In JK flip-flop, as long as clock is high for the input conditions, J and K equals to the output changes or complement its output from 1 to 0 and 0 to 1. So this is called toggling output or uncontrolled changing or racing condition. So consider above J and K circuit diagram as long as clock is high and J and K equals to 1 and 1. Then two upper and lower AND gates are only triggered by the complementary outputs, that is Q and Q bar. That is, in any condition according to the propagation delay, one gate will be enabled and another gate is disabled. So if upper gate is disabled, then it sets the output, and in the next lower gate will be enabled, which resets the flip-flop output. So what is race around condition? Race around condition means in JK flip-flop, when J equals to K equals to 1 and the clock pulse is too long, at that time the output of the flip-flop will keep on changing from 1 to 0 and 0 to 1 and so on. So this condition is known as race around condition. So this race around condition can be eliminated by using master-slave JK flip-flop. So we are using the master-slave JK flip-flop in order to eliminate the race around condition. So finally, we are learning about what is the application of flip-flop. So the application of flip-flops are, it is used in parallel and serial data storage, then it is used to transfer of data, it is used to serial, the conversion from serial to parallel and parallel to serial, it is used as a counter, it is used in frequency division. So in this manner we are using the flip-flop. So that's all. Thank you.